This is Luboš Pirkl from CFD Support, and welcome to the webinar about TCFD, the unlimited and focused CFD code. Today we have a lot of good news for you, and only good news. And as you likely know, we have just released the new TCFD version 18.10, and TCFD is now again much better than ever before. And in today's webinar, we would like to introduce it to you. So I hope everything works well. We are running live, so in case of any technical issues, feel free to contact us and we will gladly answer all your questions and comments. The webinar is being recorded and its recording will be made available on our YouTube channel later after the webinar. And I think it's time to get to the action. So please let me start with the introduction of the webinar speakers. So this is me. My name is Luboš Pirkl. I'm co-founder of CFD Support, and my current job at CFD Support is telling the world about us. And today I am here with my colleague, Radek Máca. Hello, Radek. Are you ready for the webinar?
Hello, Luboš, and hello everyone who is watching us. It is a pleasure to introduce you new features introduced in TCFD 18.10. And Luboš, yes, I'm ready.
Okay, thank you very much, Radek. I only note that Radek is our head engineer and senior developer here at CFD Support, and he will take care of the technical part of today's webinar. Okay, I think we can switch the camera off, and let's continue, and we will come back in the latest part of the webinar. Okay, so here's the agenda of today's webinar. The webinar is going to take about 1 hour. There will be 3 parts in this webinar. In the first part, I will give a general introduction to TCFD. I'm gonna point out the main TCFD features and benefits. In the second part, Radek is going to give you live TCFD experience, and he's going to present the new capabilities of TCFD 18.10. And in the last part, there will be a Q&A session dedicated to your questions and our answers. So feel free to ask your questions. Some of your questions will be answered right in the webinar. The rest will be answered later via email, but you can be sure that all the questions will be answered. So please take the chance and use this possibility. And we are here for you. It's your time, and we'll gladly answer everything you ask. Quickly about CFD Support. So CFD Support is a private engineering company dealing mainly with computational fluid dynamics. We are located in Prague, Czech Republic, and we deliver complete CFD projects. We do various projects on demand all across the CFD field. We also deliver extensive open form training and consultancy, as well as open form support and custom code development. And of course, our flagship product is TCFD, which this webinar is about. So this is just quickly about our company. And this brings me to TCFD. So please let me give a brief description. What is TCFD? So TCFD is a comprehensive high-tech CFD code. It's designed to be a complete CFD workflow to cover all the engineering steps, from the pre-processing over the simulation run to the very detailed post-processing of the results. It's independent on any other software, and on the other hand, it's fully compatible with other software. For this reason, it can be easily integrated into an existing process chain in any organization. So TCFD is unique CFD software, which is focused and unlimited. It's very progressive because it successfully merged the benefits of open source. It's perpetual, unlimited for users, jobs, and cores, and it's also very flexible and customizable. And the merged benefits with the benefits of commercial codes, like professional technical support, graphical interface. It's robust, accurate, automated, well documented, well tested, and it's ready for the industry. So the user can simply put the data in. TCF does its job, writes down the results, and in the end the user can pick the final report. So, and that's it. So TCFD, the user can TCFD can be used either as a black box, or it can be used as a fully sophisticated CFD code where all the options are open. So the beauty of TCFD is it's the user who decides how deep to dive into CFD or not at all. About the applications of TCFD, so TCFD is always focused on particular workflows by particular applications. TCFD core business has always been turbo machinery simulations, both radial and axial machines, both compressible and incompressible fluid flows. So, for example, pumps, fans, also turbines, compressors, hydro turbines, and, for example, wind turbines, and many other kinds of rotating machinery. Later, we decided that what had worked so good in turbo machinery to extend it to external aerodynamics. So now TCFD can simulate cars, aircraft, and many other external flows. And also it can simulate the internal flows like valves, piping systems, manifolds, and many others. And also it can simulate, for example, ship hydrodynamics like ship hulls and with propellers, for example. So TCFD is always focused to particular engineering workflows. That's very important. Please let me stress out just a quick review of TCFD unique value. So we believe TCFD is unique at least for reasons. Number one is TCFD is unlimited, which means our clients can keep TCFD forever, and they can use it for an unlimited number of users, jobs, and cores. TCFD gives the investment into TCFD a permanent value. So this means our clients can scale their CFD simulations in a really big way. TCFD is fully automated. So TCFD is extremely effective for this reason. We have really good technical support, and also the real preset tutorials are included. Currently there are exactly 22 tutorials that are based on the real machines and the real projects we did in the past. So the new TCFD user has no doubts about the best practice settings and how to start. There are some other technical details. I will go quickly through it. So TCFD is available for Windows and Linux operating systems. TCFD has its graphical interface in ParaView, and currently or nowadays 100% of workflow can be done in graphical interface. Of course, the batch mode is available as well, so anybody can run TCFD on the background in the batch mode. TCFD is further scriptable, so if someone wants to script it into big loops, it can be scripted in Python. What's important, TCFD has its own automated meshing system based on SnappyHex mesh, and as well the external meshes can be imported to TCFD. So we always leave this decision on our users to whether to load the external mesh or use the automated meshing system. The demo, the trial version, is available. So TCFD is very transparent. So anybody can give it a try, and after that he or she can decide whether to go for it or not. So the real tutorials are included. We have very strong post-processing tools, strong reporting tools, also turbo machinery post-processing system. We have quite good documentation and manual and videos. Most of the resources are available online, and finally our development is still in progress, and it always will be. We are always on the way, and our development is driven by the requirements from our users. So anybody can ask us to incorporate a new feature, and we usually collect the most desired features, and then we implement them into the next TCFD version. Okay, we have a few case studies to show TCFD performance. What's important, I'm not gonna go for the details. I will just quickly go through them. In case of any interest, feel free to contact us and we will gladly tell you the details, all the details we can. So I have a few examples here. So this one is the benchmark of a simulation of the real existing radial fan, for which the measurement data is available. It's a special radial fan benchmark project we did together with our partner ZVVZ Machinery. This particular radial fan is quite difficult to simulate. It has very wide wheel and very complicated airflow, including the low pressure ratio combined together with high flow rate. So this combination is very challenging to simulate for any CFD code. We did both steady state and transient simulation for complete fan characteristics, and you can see very good agreement with the measurement. This is another project we did together with our partner ČZ Strakonice. The project was aimed at compressible flow of centrifugal compressor, and again the measurement data is available, and also we have available the other commercial code results to compare with. The complete centrifugal compressor characteristics were simulated at 3 compressor speeds, and as you can see the results are in very good agreement. I'll go to the next one. This one is a detailed study we made on TCFD parallel scaling. The scalability is one of the most important features of any CFD code. As you know, in modern CFD, it's critical for any CFD code to show a linear speed up with increasing the number of simulation cores, especially for unlimited CFD code like TCFD is. The scalability is essential. So we made a detailed study on TCFD parallel scaling. The tested case was a Francis hydro turbine. The scaling results are amazing. And here are the key figures. You can see that this study clearly proves that TCFD has very high parallel scaling efficiency. And of course, the detailed PDF paper on this study is available. Yeah. So in the last year, the TCFD is being extended by the new applications. Recently, we made TCFD able to simulate external aerodynamics. We made a complex TCFD study of the Spitfire aircraft. We found the CAT model and also the original measurement data to compare with the simulation results. The agreement with the measurement was very good, and the detailed PDF study again is available if you would be interested in details. And finally, we have an optimization study. We did this study together with our German partner Friendship Systems, who developed their product called Cases. Cases is a flexible CAD platform for fast and comprehensive design studies with simulation tools. And together we made this study on a fine simulation where the optimization study was performed. Many simulations were simulated of many designs that were generated in Cases and simulated in TCFD. And as a result, the engineer we've got an optimized fan model with higher efficiency. So we did in this study, and again, the detailed PDF paper is available on request, so feel free to ask it. And yeah, so here we go. Now it's time for a live example and new 18.10 version capabilities. So Radek, are you ready? Can I hand over the presentation to you?
Yes, I'm ready. Yes, I'm ready. So you can? pass me the presentation, show my screen. Okay, so thank you, Luboš, for a very nice overview of TCFD. And my goal now is to introduce you the biggest news in TCFD 1810. So hope you can see my screen. And if so, let's start the second part of this webinar. So what is new in TCFD? So with this release, we are officially entering the external aerodynamic simulations. So for this purpose, new simulation type virtual tunnel is available. Additionally, we preset a new tutorial, which is called Dry Fire, showing the best practice setup for typical external aerodynamic simulation. Over the last years, we registered significant demand for multi-rotor simulation. So therefore, we have developed a new framework for multi-rotor simulation. So this framework we called reference frames, or it is set using the reference frame section. And we add additional features such as axis of rotation visualization, which helps the user to manage the several rotors setup. And of course, we provide a new tutorial describing this best practice setup for multi-rotor simulation, which is called double rotor axial fan tutorial. We have improved the simulation reports. User can now set individually sections to appear in the report, so they can choose for section or for quantities in which the user is interested in, as well as the report or reference quantity can be checked and afterwards appear in the final report. And finally, the improvement of the reporting lies in adding aerodynamic forces and coefficients, so now are automatically evaluated and reported. So additionally, several meshing features has been added, such as bounding box for defining boundaries of virtual tunnel, background mesh transformation for better mesh alignment with an input geometry, patch groups locking for individual mesh refinement at geometry boundaries, gap refinement for meshing small gaps, and refinement regions for mesh refinement in, let's say, user-defined regions. Last but not least, we added new turbulence models to be implicitly chosen in GUI or in TCFD setup. Then we implemented new flow rate family of boundary conditions at the outlet. We made some graphic user interface improvements, and for example, runtime relaxation parameters for very fine tuning of the solver and of the convergence process. And besides all these main features, we have made more than 50 minor changes and bug fixes. Okay, so during this presentation, I will be switching between these slides and live examples in TCFD to really see that it works and it is really implemented. I'm going to demonstrate some of the new features on these two tutorials. So first one is this dry fire tutorial for external aerodynamics, and the second one is a double rotor axial fan tutorial for representing multi-rotor simulations. So I will be switching in this way. Sorry, not in this way. So this will be the dry fire tutorial, and here I have preset and loaded into TCFD the multi-rotor double rotor axial fan tutorial. So within the new release of TCFD, we have introduced 3 new tutorials. One of them is this drift fire tutorial showing a typical example of external aerodynamic simulation. The drive fire model was developed, measured, and studied at the Technical University of Munich. The CAD geometry is published at these web pages and can be downloaded for independent studies. So therefore, there are many studies and real measurements perfectly suited for validation studies. And moreover, many variants of the body is available as well. So the solver and the software can be really deeply tested. So for example, there is many body shapes like estate body, fastback, and notchback. You can combine any part. So you can, for example, use a smooth underbody or very detailed underbody with the exhaust system, as well as you can choose the smooth tires or really real shaped tires and so on. So this is a very nice and playful tutorial. Well, the second tutorial is focused on the multi-rotor simulation. It consists of two rotors, two stators, and 3 piping sections. So quite complex geometry, showing that really almost all geometry or really complex geometries with unlimited number of rotors can be now simulated in TCFD. And the last is an example of internal flow. It is a simple hydraulic valve tutorial showing the ability of simulating internal flows. Okay, so let's start with the external aerodynamics. What is new? So I will go now I'm going now to introduce these new features one by one. So first one is the new simulation type called virtual tunnel. It can be used for investigation of aerodynamic forces acting on any object, so typically in car industry, aerospace, etc. So this new workflow gives user all the tools needed for successful CFD simulation. So therefore we developed new meshing options. We implemented unlimited number of rotating regions. So it means for cars, for example, that rotation of car wheels can be simulated as well now. We tailored the evaluation process for evaluating aerodynamic forces, and of course these forces will appear then in the reports. So just simply go here. So this is a TCFD graphical user interface. All the setups can be done using these sections. And for example, the first setup you should done when you start setuping the case is to choose the simulation type. So for this external aerodynamics, we will choose now, for this case, virtual tunnel, for example. So next part or next feature or next big feature which is implemented is a new multi-rotor simulations, which brings unlimited number of rotors with different rotation speed and axis. So the rotation is applicable for both steady state and transient simulation. And the key part of the setup is the reference frame section. So each frames, this reference frames approach defines each frame which holds the information about the axis of rotation, or in case of the static segments, the transformation, the rotational transformation of the segment, and of course the rotating speed of the particular part of the geometry. So inside the GUI, inside the TCFD source, we can find a new section which is called reference frames, in which we can define as many reference frames, rotating or stationary, as we need. For better frames management, of course, we developed automatic axis of rotation visualization. So anytime you click on any frame, the axis will be visualized. So let's see how it works. So as you can see here, we have the new section reference frames, in which we can define as many reference frames as we want. For example, here we have 2 rotors, this pink part and the red part. So I think the frame 2 represented the rotating region, so I can define the name, axis of rotation, point on the axis, and check if this part or if this frame will be rotating and at which speed it rotates. Anytime you change something, you can see anytime how the axis looks like, which makes the work with TCFD very, very easy. Okay, let's go back to presentation. So when the reference frame are preset, so then the components in the component section, the frame has to be assigned to the components, which basically defines the rotation of the whole component. The frames have to be also assigned to patches, so you can both define rotating walls in non-rotating components and non-rotating wall in rotating component. So it gives you really high complexity of defining the case. So it is depicted here, but we can show how it works live here. So basically for each component, so here we have several components. So for example, the component 2 is this rotor. So this rotor here by the reference frame is assigned to the rotating frame with the name rotating 1. And of course, all the patches are assigned to this rotating frame. For example, if we have so-called unshrouded rotor part and the shroud is physically not rotating, we can assign this type or this shroud to static reference frame, and now the shroud is set to be non-rotating. And the same holds, for example, for component 1, which is here. So if we want to rotate this hub part from the rotor, we can similarly assign the hub as to the rotating frame. So in this way, we can preset hold the case and run the simulation. So we implemented also several new meshing options. So in case you have no external mesh and you are going to mesh to create the mesh in TCFD, we created several new features. So first one is bounding box, which is a new framework for defining a box-shaped computational domain without importing its geometry. So what does it mean? It means that you don't need any external STL files to define the virtual tunnel, let's say, or the boundary of your virtual tunnel. So it can be set automatically. So the virtual or the bounding box is available for simulation or for simulation type which somehow simulate the external flows, such as propeller, stator, virtual tunnel, and wind turbine. And what is nice is that the setting of the bounding box is interactive, so you can anytime you see what you set basically. So if I go here, so this is our setup, so I can go to the components part. So another feature which is implemented in GUI, so sometimes where you have a big and complex geometry, so then the menu is quite wide. So by middle mouse click, you can undock this section and have a separated window for the setup. Yeah, so you can really nicely adjust the windows to fit your needs. And basically here at the beginning in the component section, here is the bounding box checkbox, which enable this bounding box setup. Then you just set the flow direction, yeah, so you can choose in which direction the flows will go in. It is nicely visualized directly, so you should make yeah, so you are always informed what you said. And of course, the size or the diameters of the bounding box is interactive. So if I would like to extend the virtual box anytime, I can really see immediately the shape of the virtual box. Yeah, so this is what we have here for the bounding box setup. So the next one is in the background mesh transformation. So for better alignment of the input geometry, we have developed this transformation of the background mesh. For those who don't know what is background mesh, background mesh is an initial mesh for meshing. So it is good to align the background mesh properly with your input geometry, and this transformation allows this better alignment. A typical example can be presented on this double rotor tutorial, where the axis of rotation is not aligned with the main XYZ axis. So if I go to our tutorial, so inside the component section here we can enable this show background mesh, so we can see it is preset correctly, and this advanced rotation is available in advanced mode, which can be enabled by this button. And now you appear that there is 3 slide bars or 3 values of the rotation in the Eulerian approach, let's say. So if we transform this, if you change this beta angle, so this is let's say the default value, which is not nice for this shape of the geometry, so we can really nicely align with our input geometry. So this is a very nice feature, and it's also it can be also applied for segment, for cylindrical background meshes, to really align the background mesh with your segment. Okay, so what is next? The next one is the patch groups locking. So in the previous TCFD versions, the patches of the same type always share the same levels of refinement. So levels of refinement means how fine the final mesh will be. So the new version allows to set the levels individually for each patch without any restrictions. So it can be done by unlocking the patch and basically set the values. So just to show, for example, now we can go again, let's say for this Trifire tutorial. So we can see here that all the parts of the car are set as a wall, of course. And now I would like, for example, to change the mirrors. So I would like to make mesh finer at the mirrors part. But now, or what was available in the old version, if I change here, it changes for all the types wall. Yeah, so it wasn't I wasn't able to do this. But now if I unlock this patch, so then I can use any number just for this particular patch. So which is also a very nice feature. So now the meshing is much more complex than ever before. Another feature is the gap refinement. So again, it is available in advanced mode. It is used for effective refinement of small gaps up to the defined gap ref level. So if you enable this gap refinement, okay, so maybe I will go here. So if I go for components, here somewhere here in the advanced mode again, of course, is the use gap refinement, and then a new column appears in this patch list, and you can basically increase this number to really make a mesh finer in small gaps, which is again visualized here. So a typical example is to mesh a leakage passage, for example, for this radial pump. So this part is always problematic, and it eats a lot of cells to be meshed. So now, for example, if you have only one part of the geometry for the whole casing, so then you can enable this use gap refinement, and then you can see that it uses the mesh refinement with respect to the size of the gap, so which can save a lot of cells in the final simulation mesh. And I think this is the last feature from the new meshing options, so which is the refinement regions. So refinement regions feature allows defining a simple shaped region for mesh refinement. Typically one needs a finer mesh in the wake area behind the car body or among the whole body or whole object. So the user, by clicking on this checkbox, use the refinement regions, and can enable as many refinement regions as the user wants. So again, we can show on this example. So here we have 3 refinement regions with the box shapes, but you can also use sphere or cylinder. So basically you set the dimensions and the level of refinement. Yeah, and then finally you can get something like this. So verify mesh among your objects and make the mesh coarser apart from your object. There are 2 modes, inside and outside, which is obvious that inside it mesh the inside the object, outside it mesh outside from the defined object or defined region. Okay, so what is next? So we have introduced new turbulence models directly into the GUI. So now you can, beside others, you can choose the realizable K epsilon turbulence model and RNG K epsilon model. So directly in the GUI. For example, you can go here where we have this turbulence, and simply you just choose model you prefer, turbulence model you prefer. Again, you can also set these advanced parameters in the advanced option. So if I disable this advanced option, then you can see just the turbulence model and wall treatment. Then we have implemented the flow rate outlet or new family of outlet boundary conditions. So it is a mass flow rate, volumetric flow rate, and fixed velocity boundary condition at the outlet. Simply just go to the outlet boundary condition outlet section and choose what you need. So for example, for pumps or fan simulation, it is clever to set the volumetric flow rate, if you prefer, at the outlet and not at the inlet. Okay, and now we are going to improved reporting part. So now in the post-processing section, you can, or user can, define their own section to appear in the report, as well as the report quantity. So if you enable again the advanced mode, then you can see these 2 new options, report section. So you just choose which section you want to see in the report, and the report quantity. So usually what appears at the x-axis and the reference quantity for the results. And of course, new forces section, because of our external aerodynamics. So forces and force coefficients are very important. So now they are directly visualized and presented in the final report. So force coefficients, forces, and torques. So we can show the setup and how it looks like. So okay, I need to move this one here. So here I have preset this final report for the car, and if I go to the setting part, to the setup part inside the post-processing, so basically as here our report section. So now all of them are chosen: force coefficients, total pressure difference, and total pressure per interfaces, and for example velocity magnitude per interfaces. And the reported quantity is velocity, because at the inlet we of course set the velocity. So then it's a classical report in which we can see the force coefficients, the progression or the evolving during the simulation. So we can also check the convergence, let's say, forces in each main direction, and of our torques or angular momentum along the main axis, and of course the other sections. So now everything is available at one place, and the same I can show you for the double rotor axial fan tutorial. So again, inside the post-processing, if I enable advanced option, we can see now that, for example, the report quantity is the flow rate. So we can go through, and we, for example, we can see, we can see that, yeah, that now for the reference quantity, what we can see here and here in the table are the flow rates compared to, for example, here when we set velocity magnitude. So here we have velocity magnitude as well as in these graphs. So this is another option which can be managed by the user. Then this new sections undocking. So each section can be undocked by a middle mouse click, which I have already presented. But again, for example, I need to undock these physics, components, turbulence, so I can really manage it here and not here in this properties menu. Yeah, so a small feature which can be very handy. And the last, let's say, last feature to be mentioned is the runtime relaxation parameters tuning. So it is really advanced parameter feature or advanced feature following allowing user to change the under relaxation parameters during the simulations. So it is mainly developed for testing purposes or for tuning the special cases. So therefore it is not recommended for final simulations, because when you change anything during the run, so it is not noted anywhere, so it is hard to repeat the same simulation later on. So how it works, so maybe I can go for the last tutorial, which is, let's say, this hydraulic valve tutorial. So to speed up the process, I have already generated the mesh, and now, and again, this option is available in the advanced option. Yeah, so here we have this runtime tuning. So when I run the simulation, so now the simulation is starting. Now here in this window, we can see the live residual. And if I really would like to blow up the solver, for example, so I can set this relaxation to 1. And anytime you change here, you need to apply, you need to click on this apply button to really apply these changes. And anytime it happens, you can see that the residuals goes up. And I think after a few iteration, it blows up, and there is no convergence. So again, if I go back to the reasonably small relaxation factors or relaxation parameters, the result should go down again. Yeah, so in this way you can really tune the simulation runtime, but this is really just for really rare cases or for very fine tuning or for testing purposes. Okay, so yes, I am at the end of my part. So this is all from my side, and therefore it is time to go back to Luboš. So Luboš, are you ready to take the presentation back to you?
Yes, I am, Radek. Thank you for a remarkable presentation. I'm gonna take my screen back. Okay, so we are approaching the last part of our webinar. So this was a live example and the new capabilities from Radek, which moves us to the Q&A session. So I would like to ask you to ask your questions. It's your time. We are here for you, so we will gladly answer it or answer them. So feel free to ask your questions, and we will do our best to answer them. And yeah, and of course, if there will be some, let's say, very detailed or complicated questions, we will answer them via email. So all the questions will be answered. So feel free to ask. Okay. Yeah. So Radek, can you say something? I have some computer issues here. So we can start without.
Okay, so one of the question is which kind of external mesh formats are supported? So yeah, I can take the presentation to me, show my screen. Okay, I can go for the components to answer your question by an example. So here in the components, and if you go here to the geometry source, so there is sorry for that, because I am this here in this virtual tunnel, which is not supported by. Okay, so it will be here. So inside the components here, and basically the external OpenFlow mesh, which is not so interested, but the external Fluent mesh in MSH format, so both binary or ASCII. So I think 99% of any software can convert the mesh into the MSH format, which can be afterwards loaded here. So MSH format of the Fluent mesh is supported. Okay. Will all the new features keyword for the TCFD file document in the manual? We usually don't use the GUI for the case. Yes, of course, Marcus. It will be the TCFD manual is already updated and includes all the new keywords which can be used directly within the TCFD configuration file. So markers are pointing that it doesn't use GUI, but it uses these configuration files in which it preset the simulation and then run in the batch mode from the command line. So yes, it is already updated in the TCFD manual. Okay.
Maybe Eric, maybe I can answer this.
Okay, so I see the last one, and then I will switch. We can switch to you then. So I see the question for counter rotating fans. Can I use your multiple rotor model? I would think I need to use sliding mesh model. Well, it depends. So if you can define disjoint rotor part, so for example here, I think a good example is on this double rotor fan. So if I go, okay, here's the menu of the webinar. Okay. So for example, if it is in this slide, and let's say these are two rotors with counter rotating, so it can be preset. But if your rotating components are not disjoint, so then it can't be applied, this multi-rotor approach. And so it can be applied to disjoint regions, and then there is no limitation. But if somehow the regions of these two rotors interacts, so then it can't be used now in TCFD. Okay, so I think we can switch back to Lubos.
Yeah, I think we are done. Philip is asking, hello, can you tell me where to find the release notes? Yeah, it's a good question actually. So we will be in touch with this. This webinar is about the release notes, and we have some list we can send you. So I will make a notice, and I will be in touch with this. Okay. Okay, so and the next question from you, Heol, is there a documentation for the tutorials? Well, the tutorials we have available online in our download section. You can have a look. There are 22 tutorials available to anybody for download, and kind of documentation. It's because we have like special case studies for each tutorial. So these case studies, which can be found online, are the kind of documentation of these tutorials. So the most of them, or the vast majority of tutorials, have these this documentation online studies. So if you would have any special detailed questions, feel free to contact us, and we will send you the details if you miss some. Okay, so I can't see any more questions which are easy to answer. So I guess, Radek, what do you think?
Yeah, I don't see any question as well. So maybe we can conclude.
Okay, so I'll take back the presentation, and yeah, we need to move. So we are at the end. So I think this is it from us in this webinar. Yeah, maybe we can just say hello again. Hello. So yeah, so this is it from us. It's time to finish. So stay tuned. Feel free to contact us in the future. I'm sure you know very well how to do that. We will gladly answer all your questions. We will gladly support you in your projects. So it's our job and also a pleasure. So please stay in touch. All right then. So this is it. So we leave you with that. So thank you for your attention, and we are looking forward to collaborating with you. Stay tuned, and bye bye for now. Bye bye.